Good morning everyone. My name is B. Ravi Babu and today topic is we are going to discuss about transistor. Okay. So what is transistor? Transistor is a three-terminal semiconductor device. So what are the three terminals? Such terminals are emitter, base and collector. So what is the function of emitter, base and collector? So the emitter is a function of it emits the charge carriers or which donates the charge carriers. Such charge carriers are electron or holes. Okay. So the function of emitter is it donates the charge carriers. Okay. And it is a heavily doped. That is adding of impurities which is highly doped in the case of emitter. Okay. Emitter is represented as capital E. Okay. So that is the function of emitter. So what is emitter? Emitter is it emits the charge carriers and it is heavily doped. Okay. That is very important about emitter. And what is function of base? Base is a function of collecting the charge carriers and passing the charge carriers. So where it is collecting? From the emitter and collecting and recombination takes place and passing the charge carriers from where? Base to collector. Okay. Emitter, base and collector. Charge carriers donates and collecting and passing to the collector. That is a function of base. Okay. And base is a thin layer and small size. Okay. And it is lightly doped. Okay. It collects the charge carriers and passing the charge carriers and then it is lightly doped. The doping level should be very small compared to the emitter and collector. Okay. And finally, collector. What is the function of collector? Collector is a accepting the charge carriers or collects the charge carriers from base terminal. Okay. So that is the function of collector and collector is a moderately doped. Okay. Compared to the base, it is better. Okay. That is moderate. So doping level should be moderately doped in the case of collector region. Okay. So that is three-terminal semiconductor device is named as transistor. So emitter, base and collector. Okay. Well, base is represented B and collector is represented C. Emitter, base and collector. Okay. Now in this transistor, who invented this transistor? Anybody knows? That is invented by Mr. Walter Hauser Brattain. Walter Hauser Brattain. Okay. So he is a scientist in American University and is this transistor introduced in the Bell laboratory in the year of 1947. In the year of 1947 in Bell laboratory which is introduced in the transistor. Okay. Before transistor, what type of device which is used to amplification of the different communication systems? That is vacuum tube. By using vacuum tube, they may done the many applications. But why we can replacing by the vacuum tube? By using transistor, there is some drawbacks in the case of vacuum tube. Such vacuum tubes are that is withstanding temperature, which means highly temperature will be happen. Due to that happen, there is a damages of the devices. Such devices are television. It cannot be controlled that much of heat. Is it clear? And it has larger size, big size. That's a problem in the case of vacuum tube. So there are two cases. One is withstanding temperature, it couldn't control, and next one is larger size. And also it takes more power. That's a problem in the case of vacuum tube. That's why this idea came to his mind. Who? Walter Hauser Brattain. He is the person introduced by in this transistor in the year of 1947. And thereafter, two authors supported by in this transistor. Those names are William Shockley and John Brattain. Okay, William Shockley and John Britton thereafter, which is fully implemented in the year of 1956. Okay, so that's about introduction about in this transistor. Now, what are the advantages of transistor in this compared to the vacuum tube? That is, it looks like smaller size. That's very very important. It looks like smaller size. And next one, it consumes less power. That is low power. Okay, first one is what? It is smaller size, and next one is low power. And finally, that is what? It room temperature is 27 degrees Celsius. Okay, in the case of vacuum tube, that is withstanding temperature. But here, minimum temperature, that is room temperature 27 degrees Celsius. Okay, and it is most important thing is what? In transistor, it gives longer life. That is major advantage of the in this transistor. Okay, if your device will be damages, then again you can purchasing that device and then using. But if you continuously, it will due to the temperature effect, it always damages will get. Then you cannot spend more time, more money to the devices. That's why they can invented this kind of transistor. This transistor which gives better efficiency in the applications. Okay, that's why you can go for the in this transistor. Furtherly, many applications introduced by the this transistors, and as well as FET, field effect transistor. Okay, let's see on later on classes we will go for the FET. Okay, let's discuss about now in the case of transistor. Okay, now this transistor operation is based on the two cases. One is majority and minority charge carriers. Okay, this transistor depends on the both majority and minority is called as bipolar junction transistor. Simply you can say that it is bidirectional device. It is a bidirectional. Why? Because both majority and minority charge carriers. What are the charge carriers? Either electrons or holes. Okay, there is a movement of charge carriers. That's nothing but bipolar junction transistor. So simply you can say that BJT is a bipolar junction transistor and it is a bidirectional. Is it clear? That's about this point, BJT. Okay, and finally it is where you can use. It is used in amplifiers, oscillators, and then digital circuits. Okay, where you can use this transistor in the case of amplification, or in the case of oscillators or digital circuits. Okay, later on classes we will discuss about what is amplifier, what is oscillator, and what is digital circuits. We will discuss later on further classes. Okay, now and finally, it is widely used in applications. Such applications are computers, and then satellite communication and wireless communication system. In wireless communication system, as you know that familiar, you are using mobile devices. Without cable, you are using devices. Such devices are mobiles, laptops, pages, all those things, which is depends on the antennas. Based on the antennas, we can roam anywhere, at any places. Okay, so such systems are wireless systems and computers. Computers in the sense TTL, transistor logic, and these are the comes to the in the case of computers. And satellite, analog communication, digital communication. In those subjects are which is required in this transistor. It's very very important role in communication system by using this transistor. Okay, right. So let me draw a symbol of transistor. Yeah, so symbol of transistors. There are two types of transistors. One is NPN transistor and next one is PNP transistor. Okay, what's the difference between NPN transistor, PNP transistor? And see here, the difference is look like both the symbols are similar, but the difference is the arrow of indication is occurring, outside arrow and inside arrow. Okay, so what is outside arrow in the sense? That is, that arrow is identified by the emitter side. Both the cases, both NPN transistor and PNP transistor, the arrow marks should be identified by the emitter side only. Okay, because why it is assigned by only emitter? Why you can place by the collector or base? Because the charge carriers always emit the charge carriers. Such charge carriers are electrons or holes. that starts from emitter itself. That's why that arrow marks identified by the are placed by the emitter, both the cases, NPN transistor and PNP transistor. Okay, so in case of NPN transistor, the arrow marks should be identified by the outside, which means the conventional current flows from base to emitter. The current flows from base to emitter. That's why it is named as NPN transistor. Whereas PNP transistor, see here, the arrow mark should be identified inside of the direction, inside of the arrow. That is what? That current flows from emitter to base. Okay, the conventional current flows from emitter to base. That's why it is named as PNP transistor. Now, what is difference between NPN transistor and PNP transistor? In applications, which one is they can prefer? Whether it is NPN or PNP. So, that is NPN transistor is preferring for always in the case of electronic applications. Let me tell you why they can prefer only NPN transistor. See, the mobility of electrons is faster than holes. Mobility of charge carriers, which one is faster? Electrons is faster than holes. Okay, that's why here in NP region, electrons, holes, electrons. That's why this NPN transistor always preferring for applications. Okay, right. That's why we can choose only NPN transistor in various applications. So these are the two types of transistors. One is NPN transistor and PNP transistor. You should remember the always charge carriers starts from emitter itself. That's why the arrow mark assigned by the or placed by the emitter itself. Okay. Now in both the cases emitter itself they assigned by the arrow. But what's the difference these two? One is outside arrow and another one is inside arrow. That is nothing but the conventional current flows from base to emitter in the case of NPN transistor, whereas the conventional current flows from emitter to base. That is nothing but PNP transistor. Okay. Let's see constructions of NPN transistor. So, construction of BJT. So these are the constructions of BJT. First one is NPN transistor and second one PNP transistor. So constructions means here, as we know that junction, this is what P, N, this is one junction and next one is N, P and this is another junction. In earlier we have seen, do you remember PN junction diode? Okay, that PN junction which means PN, that is what junction 1 and NP is nothing but junction 2. Okay, that is nothing but similar operation. Okay, so that is NPN which is nothing but NPN transistor, whereas PNP transistor similarly. So starts from emitter, the P, which means holes are present in the P region, in base region N type, electrons are present in the base region, and collector region again holes are present in the P region. Okay, now how it will be construction has been done, that is a N type semiconductor. Here N type semiconductor which is sandwiching between two P layers. N type is N type semiconductor is sandwiching between two P-type layers, two P-type layers, which is named as PNP transistor. Similarly, in NPN transistor, a P-type semiconductor is sandwiching between two N-type layers. Okay, that is nothing but in this NPN transistor and PNP transistor. Just take one material. Okay, that is N-type material. In N-type material, which is the middle layer, then two P-type region which is sandwiching between P-type, N-type and this N-type. Okay, so two N-type, one P-type. So middle layer is the P-type semiconductor and is sandwiching between two N-type semiconductor. Is it clear? Similarly, in N-type semiconductor is going to sandwiching between two P-type layers. So this is the way sandwiching between, that is N-type and P-type. Okay, so that is a function of NPN transistor and PNP transistor. Okay, there is a combining, that is sandwiching between one P-type and another N-type. So that is nothing but in this PNP transistor and NP transistor. So whenever junction is happen, that is here, why? Because junction will becomes, because NPN. Okay, so here this is one junction and this is another junction. So first junction is what? Between N-type and P-type. Similarly, in junction to P-type and N-type. So in this case, we need to apply supply voltage. We need to applying a supply voltage, that is biasing. What is biasing? To applying external supply voltage to the circuit. Okay, that's why. So this is nothing but what? NP. So NP is nothing but emitter base junction is always, emitter base junction is always forward bias, and collector base junction is always reverse bias. It is very important. In the case of transistor, you must connect a supply between emitter base junction is always forward bias and collector base junction is always reverse bias. Okay, in this mode only this transistor operation will occur. Is it clear? This mode only transistor operation will occur. If you connected as for both the cases, forward bias and forward bias, what will happen? That is nothing but saturation region. In that case, the transistor gets heat, then it will be heat generated, then thereafter there is lots of electrons will flowing in the circuit and heat will be generated, and finally there is a possibility to get damage. That's why they cannot use this kind of saturation region. Both the cases, forward bias and forward bias. It must be used only one side is forward bias and other side is reverse bias. Okay, whereas in cutoff region, if you use cutoff region, both the cases reverse bias, then this total circuit will get off condition. So there is no movement of any current in this circuit. Okay, so among three regions, active region, saturation region and cutoff region, only this mode only will current will flow into in this circuit. Okay, in emitter base junction is forward bias, collector base junction is reverse bias. In similar operation will occur in this PNP transistor. Okay, so this is about constructions of NPN transistor and PNP transistor. So thank you for watching my video. If you have any doubts regarding this class, please drop a message in my comment box. I will reflect in our questions. Thank you very much.